Welcome to PyCon Africa. This is the first session of the day, and we're going to have a talk by Dirk. It's an AI agent in Python, from basics to multi-agent system. Round of applause, please, for Dirk. Welcome.
Thank you. Good morning, everyone. My name is Dirk. I am from Agno. We are a AI agents SDK, open source SDK, a company built around that, and a few products built around that. And today I'm going to be speaking a bit about our experience of building agents in Python and showing some code snippets. And there's quite a lot to cover, so do ask me questions afterwards. There's also a 2-hour workshop tomorrow where we will be building agents interactively. So please come to that if you want to learn more. All right, so firstly, what is an agent? It has become quite popular, but not everybody has maybe grasped exactly what it is. Effectively, it's a piece of software where the LLM controls the execution flow. So the LLM makes decisions on what should be done when you run an agent. At the heart of the agent is the LLM, the GPT-5 or Gemini or Claude, and it has a bunch of tools, so it can perform actions, it has memory, it has history of a conversation, it has external knowledge. All of that together makes an agent. When you interact with the ChatGPT app, you are interacting with an agent because it remembers things you have said, it allows you, it can search the web, etc. So ultimately, an agent analyzes information, makes decisions, and then acts on your behalf. This is a little diagram that kind of shows more or less the flow. Agents these days are quite powerful, and there's a wide array of features. You can pass text, images, audio, video to an agent. It can also generate text, images, audio, video, also files. You might have tried to have ChatGPT generate a PDF for you. That is part of what an agent can do. And then to supplement the functionality of an agent, as I mentioned, memory, knowledge, tools. So this is a very basic example of an agent. We define a model, the LLM, the heart of the agent, in this case Claude Sonnet 4, and we give it a tool, in this case tools to search Hacker News, and we tell it, please produce Markdown, please answer in Markdown. And then you can ask it a question, go fetch 5 stories from Hacker News, summarize it, give me a little paragraph. So this is the most basic form of an agent that you could have. So I'm going to be taking you through 5 levels of building agents up until building a multi-agent system. So the very first level, level 1, is we give it tools, we give it instructions on how to behave. So a tool is a Python function. It can really be anything. It can call an API, it can access a database, it can access your local file system, anything that you can think of. Some good examples of tools are like sending emails or using your calendar, but also then generating images, generating files. Then we also give the agent instructions on how to behave. So here is a more complete example. Here we give it DuckDuckGo tools, so tools to use the DuckDuckGo search engine. And we give it instructions. Please use tables to display your data. Don't include any other text, only tables. And then we ask it to go find the latest stock price of Apple. And then it'll produce a little table for us. All right, here's a slightly more advanced example. Probably some of you have heard of MCP. It is a protocol for defining tools that are a standard protocol out on the internet. And it's a way for allowing agents to access tools in a standardized way and for companies to publish tools in a standardized way. So in this case, we have an MCP tool server pointing at our documentation, and we can then ask the agent questions about our documentation, like how to build agents in Agno. And it can then use that tool, search the docs, answer questions. All right, level 2. So next, we'd like to maybe persist that conversation. We've been asking the agent single questions, but what if you ask a follow-up question and you refer to a previous question? That doesn't natively come with an LLM. LLMs are just models. What an agent does is add persistent storage so that you have that conversation history available. And we can also add knowledge. Knowledge base is effectively a store of information that the agent can search, information that it doesn't otherwise have access to. Maybe if you build an agent for a company, then it would have company documentation or proprietary information or websites that you've scanned, and then memory. If you've used ChatGPT, you might have noticed it remembers stuff you've said before, not just the questions you've asked, but facts about you. It knows that I code a lot of Python. So if I ask it for a code snippet, it knows to produce Python. And that memory we call user memories, and that is also a big part of the DNA of an agent. So here is a little example. Read like this. On the left side, we define a knowledge base. We give it a vector DB. I won't go into the details of that, but that is a way that allows us to store knowledge in a effectively searchable way, so that you can do semantic search on it. We add some knowledge. In this case, we're adding a markdown document from our documentation. We define our agent. We give it the knowledge base. We give it a DB, so storage, so that it can store all of the requests and responses, the runs, the session. And we have a flag there, add history to context. So now, every time I ask a question, it goes and fetches, in this case, the previous runs, adds that to the context that I send to the agent, to that system message, if you're familiar, and it has that context. So if I ask it, what are agents? And then it answers me, and then I follow up with, what have we been speaking about? It would have that context of that previous conversation. So, a bit more about knowledge. Anything can be knowledge to an agent. So typically you would have PDFs or CSVs that you add. With Agno specifically, you can also scan web pages and ingest that into your knowledge base. You can search Wikipedia and add knowledge from Wikipedia, code, etc. Then something you might have heard about before, and there's another talk about RAG as well, Retrieval Augmented Generation. The traditional approach to RAG is you ask a question, like I ask, what are agents? And that question gets used to inject knowledge into every request made to the agent. But whether I say, what are agents, which is a relevant question, or I ask it how to make pizza, it'll still inject whatever knowledge it finds. So that is traditional RAG, and it is quite heavy on context. Agentic RAG is you give the agent a tool, and you tell it, search the knowledge base when you need it. So you put that responsibility over to the agent, and it can find relevant knowledge when it needs to. All right, next level, reasoning. So again, if you've used ChatGPT, you might have seen it, before it answers a really complicated question, it has a few status messages, and it's thinking, and it's reasoning, and it's going through a bunch of ideas before it answers your question. Try asking it something really philosophical, difficult philosophical question, and you'll see it churn. So that wasn't possible until about a year ago. Before, it was pure LLM answers. It would just answer directly. A famous example that it would get wrong is if you ask it what is bigger, 9.9 or 9.11, obviously, mathematically, 9.9 is bigger, but if it reads it as text, it thinks 9.11 is bigger, because textually it makes sense. But with the addition of reasoning, and it can think about how to answer that problem, it immediately can solve problems like that. So reasoning has been a massive leap forward for LLMs, and you can enable reasoning for agents. So there's two basic approaches. Chain of thought is what you typically see in a ChatGPT app. It goes through multiple steps of thinking about how to solve the problem and then solves it. React is what we like to use in agents. That's where you give the agent a scratch pad where it can put down an idea of how to solve the problem, then attempt to do it, then analyze the result, and then do that in a loop. So if it can do that in a loop, it becomes really effective at problem solving. So as I mentioned, the reason we want to introduce reasoning to agents is to solve more complex problems. Here is a very small example. GPT-5 Mini is a native reasoning model. It has built-in reasoning. So if we ask it a problem that requires reasoning, like the trolley problem, it will do a bit of thinking before it answers your problem, your question. Okay, next level, teams. All right, so we've built single agents. A big problem with single agents is you might be tempted to give it all the tools in the world to solve any problem that you can throw at it, or give it massive pieces of instruction because you want it to deal with any case that you throw at it. But LLMs has a limited context window. It can only handle so much information before it gives up and gives you very inaccurate answers. So a more effective strategy is to have single agents with single responsibility with only the few tools that matter to them, and then put them together in a team. And that way you can have a team leader that delegates the correct task to them. A good example would be for customer support. You know, customer can ask maybe 5 categories of questions. So you have 5 agents to deal with those 5 categories, and a team leader that decides which of them is the best one to delegate to. And the team leader then also takes the answer back from the team members that it delegates to, combines that answer into a cohesive result. So why do we do this? Why do we have teams? As I mentioned, the members have designated roles, and they've got designated tools, and they are more accurate in their singular role. The context becomes too big for a single agent, so now you can have a single agent only care about their part, and the team leader can manage the context, and simply divide and conquer. If you need to do a bunch of tasks at the same time, the team leader can delegate to multiple agents at the same time, and they can run concurrently. Right, here is a little example. Again, read left to right. So we defined 3 agents. This is a very silly example because LLMs can actually speak multiple languages, but let's pretend they can't. On the left, we define an English agent, Japanese agent, and French agent. So they have very specific roles. They have to answer in English, Japanese, and French. Then we construct our language team. We give it 3 team members, and we give it instructions. If the user asks in a language that you know, ask the relevant member agent to provide the response. If it asks in a language that you don't know, answer in English that you don't support that language. So then if we ask, how are you? The English agent will kick in. If we ask, how are you in Japanese, which I don't know how to say, then the Japanese agent will kick in, similarly French, and if we throw Italian at it, it'll say, I don't speak Italian. Sorry, I don't have a member that speaks Italian. So, very silly example, but this kind of shows the power of introducing a team. All right, the last level, there's 5 levels. Level 5, teams are ultimately still completely agentic. They make decisions on which members to delegate to. If you want to build a sequential workflow of steps that solves a problem in a very specific sequence that you control, a team is just not reliable enough to do that. So that's where a workflow comes in. You effectively build a state machine of steps, and it's a combination of Python functions, agents, and even other teams, and you can solve problems much more reliably. So the reason you do it is for predictability, control, and so that you can get consistent results. All right, this is a kind of a diagram that shows how it works. It takes various forms of input, and then the workflow itself consists of various steps until you get the final output out at the end. All right, this is over 3 slides. So here we define a web agent, and we give it DuckDuckGo tools again. We tell it you are designated to search the web. But we don't want the user input to just go to it directly. We want to do a bit of pre-processing of that. So we take whatever topic the user gives us and tell that agent, you have to write a blog post about this topic, search the web for articles. Okay, so this is our first agent and a little bit of a pre-processing step. Second agent has to write the blog post. So we tell it, you're writing a blog post on the topic, and we give it the results from our previous team's output, or agent's output, and that is our kind of prep step before the agent kicks in. So if we put it all together, this is our workflow, blog post workflow. We have prepare input for the web searcher, then the web agent, then prepare input for the writer, and then the writer agent. So this gives us a very deterministic flow for producing a blog post, in this case about AI trends in 2025. All right. So now we want to take all of this to production. We want to scale this up, make it actually useful, productive software. So a way to make agents accessible on the web is to put them behind a web server. There's obviously multiple web servers available. Fast API has grown tremendously in popularity. We have built a solution as well that basically uses Fast API as the base app for that. It just adds a bunch of endpoints that we've pre-built so that you don't have to reinvent the wheel. So figuring out how to stream agent content, for example, is a tricky problem to solve. So it's useful to just have a pre-rolled API that you can use. And integrating your agent with various platforms like Slack, WhatsApp, etc., as a very specific protocol. We've integrated that protocol so that you can just pick Slack off the shelf and say, I want to make my agent Slack compatible. You might have heard of A2A and AGUI. They're various protocols for exposing agents to the web. So here's a little example. We call our Fast API wrapper Agent OS. It is just a Fast API app. But as I mentioned, it has the endpoints pre-built into it for running agents, for getting your list of agents, for getting access to the session history, for managing memories, etc. And in this example, we create an agent, we give it to our agent OS, and we call get app. We get an app, the Fast API app. Then you can run it with Fast API just like you would run your own Fast API app. This produces a live API, and we have a little UI that you can use to then chat with your agent via this API, manage your session history, evaluate the agent, see running metrics, etc. So I won't go into the details of this, but feel free to come ask me afterwards. It's very useful for playing with agents, for experimenting and testing. All right, so where do we go from here? Agents are extremely wide. I've only covered maybe half of the topics of what agents can do. There's still so much. The best way is to play and experiment. We often get people asking questions like, what's the best way to do this? And often the answer is there isn't really a perfect answer, because you have to experiment and see, with this model, with these instructions, with these tools, does it solve my problem? And nobody's going to be able to answer that for you. So experimenting is the best way. Python best practices are still important. That's why we went for Fast API. It is very scalable. Leveraging concurrency so that you have performant agent runs is very important. So running agents asynchronously, for example. And then you're going to build your own tools. They should be efficient. It doesn't help your tools run forever, and it makes the overall agent latency longer. And then database practices. So something we've introduced recently is guardrails. So you can imagine if you have a user asking support question and the user is inputting their credit card because they don't know any better. You'd like to prevent that. You'd like to prevent that credit card number from going to ChatGPT, going to their servers. So that's what a guardrail is. It stops invalid, malicious, or incorrect user input from reaching your LLM. And that's the sort of stuff you have to keep in mind when you're building bigger agentic applications. All right, that is me. Tomorrow there is a workshop where we will be going through most of these topics and building these agents together. So I would encourage you to come to that. But I think we are good for questions.
Thank you so much for your talk. So we have like 15 minutes. If you have any questions, this is the time.
Thanks for the talk, very insightful. Question is regarding how does this workflow framework, particularly on level 5, compares with tools like LangFlow?
So Lang flow and lang graph.
Yeah.
Yeah, various ways to build these workflows. Lang graph in particular is much more node-based. You take nodes, point nodes at each other, etc. And this is our approach in general to agents to workflows are to make it as simple, iconic as possible, to make it basic Python, not require you to kind of build pointers and stuff. It's not very like that. So in effect, they do the same thing. You can build the same solutions. The approach is just it's like ultimately we both build the graph. The approach of building the graph is like
Sorry, one last addition to the question. And do you have any built-in evals framework in Agno?
So we have evals built into the framework. It is still relatively basic. So we have what's known as LLM as the judge. So your agent produces a result, and these results are obviously fuzzy. You're asking a fuzzy question, you're getting a fuzzy answer. How do you evaluate that that is correct? You ask another LLM with very strict guidelines to evaluate it. That is pretty effective, but that is not enough to determine accuracy. You also want to know, does it call the right tools? Does it fetch the right knowledge? Does it do what it needs to do always? And what we really want to get to is to do simulations, so where we can compare different agents. So you take one agent with one set of instructions, another agent with another set of instructions, compare them against each other and evaluate their output relative to each other. So that's kind of where we're heading. But yeah, we have evaluations and it's LLM as a judge. Any other questions? Yes.
Yeah, thank you for that presentation. I just want to check on the infrastructure requirements. I know that you kind of gave us a lot of insight into the dev aspect, but what are the LLM aspect in terms of, is it a local LLM that you built on-prem, or are you accessing something in the cloud? And what is the cost for that? Because what I'm hearing from the industry, it's quite expensive to run these agents in South Africa when you need to access a lot of the infrastructure that is sitting outside the country. Do you have some challenges around that? Thanks.
All right, so we also build agents with our own framework. We don't host as many agents as, say, our customers or users do. But yes, that's definitely a challenge. Ways to overcome climbing costs is obviously to use smaller models. Even proprietary smaller models these days are pretty cheap and very strong. So I showed GPT-5 Mini, very cheap, very strong, but still those costs can add up depending on the application. So local models that you host in your own cloud application, for example, on AWS, Bedrock, for example, that can really reduce costs significantly. It very much depends on the use case. It's very important not to use a model stronger than you need to. If you don't need extreme variability in tool calling, you don't need a very strong model. Very, very small open source models can answer questions very efficiently. So using the correct model is probably the best way to do it. Context engineering is very important for reducing token costs, so that you don't send information to the LLM that it doesn't need to perform the tasks. Yeah, in terms of infrastructure, it's really up to everybody how they want to host it. Ultimately, what you have is Python, maybe behind an API in a Docker container that you can put where you need to. But yeah, the external LLM costs is really what you need to keep an eye on. Yes.
Hi, how are you doing? I just have a general question maybe. How do you know when it's the right time to use an agent versus almost just building something that's not agentic?
Yes. Don't throw an agent at everything. So agents and teams are really useful for taking vague problems. If you have vague user input or non-deterministic user input, it is a great solution because it is a language model. It addresses language questions. If you wanted to produce code, that's a very good use because it's language. If you wanted to deterministically like fetch your emails, you don't need to do that. You can just write a Python function to fetch your emails. You don't have to ask an agent to fetch your emails. If you want anybody to ask any question and that might result in fetching emails, then an agent is appropriate. So it takes the non-deterministic and makes it hopefully somewhat deterministic. But it is not a replacement for good old Python. Yes.
Sorry, I noticed in one of your snippets that you add sources to your agent's knowledge, you'd say. Do those knowledge have to be clean knowledge, or, for example, if there's PDFs that scanned somewhere, will the agent handle that sort of pre-processing or not?
So the process of adding knowledge, whether it's a PDF, CSV, a web page, whatever, is there's a parse stage, a read stage. In the case of a PDF, it's literally parsing the PDF, taking the text out, taking images out, whatever, then breaking that up into individual chunks, giving that to an embedding model to produce vectors so that you can put it in your vector DB. Because ultimately what we want to end up with are vectors so that we can do semantic search. We want the agent to find semantic similar knowledge to the original query, not keyword knowledge. So yes, in the knowledge base, that pre-processing is handled. You just give a raw PDF, raw web page. We have, for example, like a Firecrawl reader. If you've heard of Firecrawl, you point it to a website, it scrapes that website, and ultimately it just injects that content into the knowledge base, which gets embedded. What you end up with is embedded knowledge, whatever the source is.
Previously, I used the multi-agent system developed in Java. It's called Agno. I'm not sure if you're aware of that. So, okay. My main question is, how is it different from the, maybe beside the fact that they're programming different languages, but how is it actually the advantage of using this multi-agent system than the other ones? The main advantage that you can tell me.
I mean, I don't know that other framework. So I don't think I'll be able to answer. But yeah, I've not used Java frameworks for this. There's quite a few popular JavaScript frameworks as well. Yeah, I wouldn't be able to tell you the difference. Anything else? All right.
Thank you. Thank you so much, and see you in the next session in 10 minutes. Yeah.